Okay, now I'm assuming by now that you've had to use the limit definition of derivatives to do some problems, and you've already hated a lot. Okay, it is not fun, it is not easy, it is very tedious, involves a lot of old algebra skills you're getting out of the closet, and thank goodness a lot of rules have come out of that limit definition. And if we just remember them, we don't have to go and do it the long way every time. So it turns out that you have some derivatives that you can just remember, and you will because we're going to do enough of them. And you won't have to go through that long process of figuring out what the derivative is, doing the limit. You'll just know, okay? So these rules are in that packet that I gave you. Basically, this one says the derivative of a constant is always 0. So the derivative of 10 is 0. The derivative of 25 is 0. The derivative of negative 10. Think about it. If you have a constant like y equals 10, that is a horizontal line. And the slope of a horizontal line is, ding, 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 0, right? So that hopefully makes sense to you why the derivative of a constant is always 0. The other one is the derivative of x is always 1, okay? Think about it. Y equals x. The slope of y equals x is 1, right? 1 over 1. And this one, the constant multiple rule, well, I'll get to that one in a minute. And this is the one that you will use a lot. This is the power rule. Basically what the power rule says is if you take the derivative of any x with a power, you bring that power down in front and you subtract off 1 from the power. So I'm going to do some examples of this and you will get the hang of this one really quickly. So for example, the derivative of this, so I'm going to use the proper notation here, is I bring the 3 in front, 3x, oops, times my pen doesn't want to write correctly, squared. So see, I brought the 3 in front and then I subtracted 1 from 3. So this is the derivative of x cubed, is 3x squared. This one is a little trickier. I want you to remember some of your exponent rules. You can rewrite this as x to the 1/3 power. Hopefully you remember that. Then you bring the 1/3 in front. Sorry, there. Oh, this is not working nice. 1/3 in front. And then you subtract 1 from the exponent. When you subtract 1 from the exponent, you can do 3 over 3. That might make it a little easier. So you're going to get negative 2/3. Okay? This is also the same as 1 over x to the 2/3, if you remember your exponent rules. Hopefully you do. Same idea here. You want to rewrite this with the negative exponent in order to use the power rule. The negative 2 comes in front. Negative 2 times x. We subtract an exponent. We're going to get to the negative 3. Okay, we can also, so this would be y prime here. We would also could write this as negative 2 over x to the 3rd, if you remember, like I said, your exponent rules. The constant multiple rule just means if you have just a constant in front, you can just leave it there and find the derivative of the function. So here, this is an example of that. Basically, this is the same as 2 times x to the negative 1, right? So basically, you can just leave the 2 out in front here and find the derivative of this. So the negative 1 would come in front, x to the negative 2 power. So essentially, this is the same as negative 2 x to the negative 2 power, or you could write it as negative 2 over x squared. Okay. Moving right along. Sum and difference rules. So when you're finding the derivative of a bunch of functions added together, you can just find the derivative of each individual function. So basically what you can do is if you have something like a polynomial, you break it up into little functions. So you find the derivative of this, then you find the derivative of this, and you find the derivative of this, and you add them all up. If you're subtracting, then you would subtract them, okay? It's pretty straightforward. So for example, the derivative of this is going to be, we're going to bring the 3 down in front, 3x squared, minus 4, okay? And then the derivative of a constant is 0. So we're done. This is the derivative of this polynomial right there. And then we have, and I'm going through this quick, some derivatives of sine and cosine. So these are ones you're just going to want to know. All of these derivative rules you're just going to need to memorize. I say memorize, but you're going to do them so often you are going to know them inside and out. We are going to do a lot of practice with these, and you are going to know them. And hopefully you know where they come from. These all come from that limit definition. There are proofs of all of these in your book, or you can find them online. Some of the proofs are in that packet I gave you. So if you want to look at the proof of these from, finding them the long way with the limit definition, then you go right ahead and check those out. So the derivative of sine is cosine, and the derivative of cosine is negative sine. Okay, so if you can remember that, it makes these derivatives quite easy. So the derivative of sine is cosine. So this would look like this, cosine x. Sorry. And the derivative here would be, the derivative of x is 1, okay, plus the derivative of cosine is negative sine x. Okay, so to write that a little bit better, I suppose I could do 1 minus sine of x. Okay, and we're going to get into a lot more derivative rules and how to use these things, but this is just the beginning. If you learn these really simple, easy rules, you're off to a great start. Also in this section is not related rates, but rates of change, which hopefully you remember when you worked with linear equations. A slope is a rate of change. A rate of change is slope. So we are going to talk about some of those problems coming up really soon.